We're going to be simplifying some Boolean expressions using Demorgan's laws. And just to jog your memory, Demorgan's law states that if you have a not over an expression, as I do right here, I have A and B not, if you break up that not, you have to change the operation. So not A and B is the same thing as saying not A or not B. And of course, if I have an or expression, A plus B with a not over the whole thing, if I split up this bar, I end up with not A and not B. So when you split up a bar, you've got to change the operation from a plus to a multiply, or from a multiply to a plus, or and to or to and. And of course, the other thing that you might want to keep in mind is if you have some kind of expression, doesn't matter what it is, if you have two bars over the exact same thing, the same length bars, you can eliminate those bars, right? This is like saying not, that's a double negative. You can get rid of those bars. However, if you have something like, sometimes students get this mixed up. If I have not A and not B, if I have a bar over this, I cannot cross out these bars. I cannot do it like that. So I could split this up and do a little bit more simplification, but the rule is if you have two bars the exact same length, you can cross them out. So I'm going to go through a few examples, and I hope you pause the video before I give you the solutions and try each one. Let's take a look at our first example. So this is a pretty messy looking expression, and generally I like to split the bars from the top down. In other words, I'm going to split it here as opposed to starting from the bottom and kind of going up, and I think you'll see that this involves less steps. So I'm going to split the bar right here, and of course that becomes, the and becomes an or multiplication becomes addition, if you want to think about it that way. So here I have split this bar, so now I have a double bar over there, and this becomes a plus. Y or Z, and that's the other piece of the bar. So I think you see what happened, right? Chopped it here, and that's what I have remaining. Now, this is the other thing that you have to keep in mind. If you have the exact same bar length over or doubled like this, in other words, I have this bar is the same length and I have it twice. I'm knotting both of these things twice. I can really eliminate that. That's a double negative. So I can get rid of those things. So that leaves me with X not Y, and actually I'm going to chop this guy, and that's going to give me a not Y, and this of course becomes an and, not Z, and of course this not Y I can also get rid of. And that is it. I think I am done here. So I have X anded with a not Y, or Y with a not Z. And that is it. So stick around for a few more examples. Here's another example, and the other thing that you might want to keep in mind, besides kind of splitting from the top down, is whatever the order of operations is in the original expression, you have to maintain that order of operations. So if I split this A and B, I can't. I have to maintain that this expression comes before the addition, even if this becomes a multiplication. I think that'll be clear as I do it. So sometimes I put parentheses in my expressions before I start chopping up bars. All right, I'm going to chop it right here. And I have now A, B with a not. And of course, this becomes an and. I put a little dot for and. And this is not B or C. Right, I've chopped it right there. Now I'm going to chop this guy. And this is what I'm talking about. If this becomes a plus, and let's see, I'm going to keep parentheses here. Well, let me actually just do it without parentheses. You can see what's going on. I'm going to chop this guy. So now this becomes an and. Right? If I didn't have parentheses around here, you would think that just this not B gets multiplied by this term. But that's not the case. So really, I like to put parentheses. It's important to keep them here. So now you can see that this entire term is getting multiplied by this guy. And of course, not B is just B. I guess I could put parentheses around here as well, but now I'm left with this guy, which I have to then distribute to the other term. So let me just do that distributing. I have a not A multiplied by a B not C, and then I have a not B multiplied by A, B, not C. And of course, you know this rule of Boolean algebra. If you have something and its opposite like this, ANDed together, that's a 0, right? If I have not B and B going into an AND gate, this becomes 0. 0 ANDed with anything is just 0. So this whole term is 0, and I'm left with not A, B, not C, or 0, which I just get rid of. I'm left with not A, B, not C. And I'm kind of running out of room here on the bottom, but that is my final expression. Isn't that simplified? All right, stick around for a couple more. Let's do just one more example. I'm going to split the bar right here, and I have not X or Y or not Z. Now I have 2 bars over this whole mess, and that is now multiplied or ANDed with the second term right here. Now again, I like to maintain order of operation. You have to do that, so I'll put parentheses around here. Now of course, 2 bars over the exact same thing. I can cross that out, I can cross that out, and this doesn't look too bad now. I'm left with not X, Y, not Z, which I now have to distribute over this second guy right here. So it doesn't look too bad. Not X times X, of course, is 0. Hopefully you remember these basic rules. Now I have not X times Y. I'll just not XY. Then I have to do the second guy, so that is X times Y. Then Y times Y, which of course is just Y. And now I have to multiply the last term. That gives me X, not Z, and Y times not Z. All right, I'm sure I can simplify this somehow. Well, that 0, of course, I can get rid of. Well, these 2 terms, I can factor out a Y, and I'm left with a not X or X, which is just 1. So that gives me a Y. And the second term is Y. Well, that's interesting. These third and these last 2 guys here, I don't know if I can simplify those. Let me just copy them over. Oh, actually, well, Y or Y is just Y. This term and this term, I can factor out a Y. I hope I don't run out of space here. Oops, I factored out a Y, excuse me. And I'm left with a 1 or not Z, which of course is 1. So this is just a Y times 1, which is just Y. In other words, these 2 terms become Y. So I have a Y or X, not Z, and I think that is it. All right, your turn to give it a try on some examples.